So 3-4 is about operations with functions and function composition. Most algebra teachers do touch upon functions. Sometimes we look at it from a graphical perspective compared to just looking at the algebra a little more than an algebra teacher will do it. We are going to keep touching upon graphing parabolas. In last week's notes, we did a parabola that was more of this form. So when we talk about graphing parabolas, if it is of this form, the vertex happens when x is equal to 0. So all you have to do is plug in 0 and then plug in like 2 points above it and 2 points below it. Be careful. One of the things I noticed that some people were doing is you have to square the input before multiplying by whatever a is out in front. Okay. Now, what that a's job, this a right here, the job of that will be to possibly stretch or condense the graph. If it's a negative, it will flip that graph upside down. So just get in the habit of kind of looking, oh, I've got a squared, so that's a parabola. If my front coefficient is positive, it's a parabola going up. If it's a negative, it's a parabola going down. So just keep all that in mind when you want to graph a parabola like that, okay? So if it has no other terms and it just has an x squared, it is always going to be a parabola with vertex of 0. Now, what I want to talk about more specifically today is what do we do if it is in standard form? So this is a parabola in standard form. The vertex is always going to be at negative b over 2a. So that is the x portion of our vertex. So our vertex will always be, the x will always be negative b over 2a. Once you get that value, you just stick that value into the function, and that will be the y that goes with it. I mean, that makes sense for any function. If you know the x where something happens, just stick it in the function, you're going to get the y that happens. Usually they will notate this as h and k. That will go with some notation we do later on. So h is negative b over 2a, and k is the function at negative b over 2a. So you just stick h in. Okay, so you'll notice that on my chart, the middle value I would always stick in as my vertex, and then just from that point go equidistant and plug in 2 things below it and 2 things above it. So I can't tell you what to plug in until you find what the vertex is. So if the vertex is 2, you're going to plug in 3 and 4. That will be higher than it. Negative or 1 and 0, which would be lower than it. Just logical. So once you find the vertex, a parabola is always going to have symmetry. So if we find that vertex and then we just plug in things equidistant on either side. Now, it doesn't have to be 1 away on either side. That is common. But if your vertex happens like at a half or something funky, you can't add a half to add a half and subtract a half, or you can add whole numbers as long as it's equidistant, because remember, these 2 should match and these 2 would match. Okay, so let's take a look at 2 examples. In our first example, you will notice that we just have a squared term. So we know here that our vertex happens when x equals 0. So we definitely want to plug in 0. Now, we could plug in 1 and -1, 2 and -2, 3 and -3, but because of that 1/4 there, we're not limited to plug in something 1 away. 2 squared is 4. So if we plug in something that's even, we actually will get something even nicer. So I'm going to plug in -2 and 2. And I'm going to plug in -4 and 4, just so that I can, that 1/4 will make it so that it's not hard to graph those points. Now remember, you're going to square it first before we multiply by the 1/4. So 0 squared is 0 times 1/4 is still 0. So that part's nice. Remember, that's our vertex. If you plug in 2, when you square it, you get 4. A fourth of that is 1. Now, -2 should give us the same thing. When we plug in -2, remember, when we square it, it is in the parentheses, so it is done first. That's why it becomes a +4, and then a fourth of that is still 1. If you have chosen the correct vertex, these should always match in a parabola. If they don't, either you chose the wrong vertex or you didn't plug it in right. If you plug in 4, you get, when you square it, 16. A fourth of that is 4. So now let's go ahead and graph our parabola. So we have a point at 0, 0. At -2, we're at a height of 1. At +2, we're at a height of 1. At 4, we're at a height of 4. At -4, we're at a height of 4. So you should expect that it looks like a U. What the 1/4 does is it kind of condenses it closer to the x-axis. So you can think of that cup is just pushed down. It's a fourth height of our parent function. Our parent function would be in here. And so you'll notice that it has been smushed down closer to our x-axis. So if you just see the x squared, our vertex is 0, and so it's pretty straightforward. You can still use that -b over 2a formula. Our a is 1/4, our b is 0, and -b over 2a would still result in a 0 vertex. Any questions on that first one? Okay. Now let's do one that has it's a little more complicated here. So when you see one like this, first thing I would suggest doing is calculating -b over 2a. That is going to find our vertex as x. Now, -b over 2a, our a is 1, our b is 2, our c is -8. So that's just the a, b, and c that we would use in the quadratic formula, the same a, b, and c that we used before. The b is 2, so when we do the opposite of that, we get -2. A is 1, so 2 of those is 2. So our vertex is at -1. So in the middle of our chart, let's choose -1. Some other nice things to know about this parabola. If you wanted to find the intercepts of it, if we set x squared plus 2x minus 8 equal to 0, if that is a factorable quantity, which it is, that's x plus 4 times x minus 2. We can use the quadratic formula or factoring to find where it hits the x-axis. We can find those x-intercepts. So we have an x-intercept at -4 and at +2. Those are always nice points to put on our graph. Now, if it's not factorable, you can use a quadratic formula to find those. It depends on how it ends up working out mathematically. Now, we need to plug in some things around our vertex. So let's go -2 and -3, and then 0 and 1. So I just went one step below it and one step above it. Now, when we plug in this one, we got a little more work to do, okay? Because of the fact that, we have to plug it in to our function here. So let's practice plugging into that function. So if we plug in -1, we get -1 squared plus 2 times -1 minus 8. I would suggest using parentheses, okay? -1 squared is 1. 2 times -1 is -2. Minus 8 is -9. Now we're going to do that with every value, but what's really cool is if we chose right, -2 and 0 should get us the same thing. +1 and -3 should get us the same thing. So I'm going to plug in 0 next, because 0 is nice usually to plug in. That's actually always going to be our y-intercept. If I plug in 0, I get 0 squared plus 2 times 0 minus 8, or negative 8. Now, if you plugged in negative 2, you would find you get the same exact thing. You get negative 8. And now let's plug in 1, so we know what's happening there. So if we plug in 1, we get 1 squared plus 2 times 1 minus 8. 1 squared is 1. 1 plus 2 is 3. Minus 8 is negative 5. I think that's right. Let me see one more time. 1 plus 2 is 3. Minus 8 is minus 5. So negative 3 should result in the same thing. Okay? Now, we got lots of information now about our parabola. Okay, so if we go over to our graph, I always put the vertex on. And get in the habit now, this one up here, I did not label it, but we can label the vertex right there. But let's go ahead and label our vertex. So at 0, negative 8, oh, I'm sorry, never mind. That's not quite it. At negative 1, negative 9, I have a vertex. At 0, I'm at negative 8. At negative 2, I'm also at negative 8. At 1, I am at negative 5. At negative 3, I'm also at negative 5. But I also have these. You can add those on. So then you really get the correct width as you're going up. We hit the x-axis at negative 4 and at 2. And you can see, hopefully here, that there is an axis of symmetry. We are equidistant on both sides of that line of symmetry. So that's just a good visual that you can use. And so our parabola looks like that. Now, you don't have to put the axis of symmetry on. You can if you want, if that helps you visualize how it opens up. But you definitely want to label the vertex for me and then get your points above and below it. Do we have any questions about that one? You okay? Okay. You can plug in multiple points, you know, if you get, but just make sure once you get the vertex, use that negative b over 2a. Then I just from there, I went 1 above it, 2 above it, 1 below it, 2 above it, or 2 below it, and then there should be a symmetry there as you plug those things in. Okay. And then below it, there's just 4 parabolas. Please tell me, label the vertex. Okay, so find 5 points for me. You should be good to go for those. Remember, the vertex's x is at negative b over 2. Negative b over 2a will help you find that vertex. So make yourself a little table next to each one. Plug in the vertex, 2 below it, and 2 above it. So that is 3, 4a. And then I just want to move on and work today on 3, 4b as well. Now, 3, 4b is about function operations, which hopefully last year you had done in your algebra class. But if you didn't, I'm going to walk you through the process. If you see, now remember, function notation says f of x. So that is just saying I have a function of x's, I am inputting x's into my function. Here, if we see f plus g next to the x, that is just a mathematician's shortcut way to write f of x plus g of x. So it makes sense that if there's a subtraction between them, that's just really f of x minus g of x. A closed-in dot is going to be different than an open circle. That just means multiply the two functions. So it's just f of x minus g of x. Put those in parentheses so you don't mess up the actual multiplication if you might have to distribute or something like that. And f over g is just a shortcut way to write f of x divided by g of x. Remember, the denominator is not allowed to equal 0. You might have some excluded values for that. And usually you might reduce it a little bit if you can factor it. So those notations are not, it is intuitive what you think. If you see f plus g of x, they want you to add the functions together. F minus g of x, they want you to subtract the functions. F times g, they want you to multiply the functions. Use parentheses, especially in multiplication and division. Use parentheses. Otherwise, it can throw you off. So I would always suggest using parentheses. So we have two functions. We can combine them. We can add them, subtract them, multiply them, and divide them. You just have to follow the rules of order of operations. It's the main idea to think about. So let's practice doing these operations. We're going to have some functions, and we're going to practice doing all these things to it so that you understand the notation and that you can work on it before we do something called a composition of functions. So we have these functions, R and S. So you see our functions right here, R and S. And they just have asked us to subtract the functions, add the functions, and multiply the functions. That's all this means right here. Okay. Let's start with their subtraction. To subtract them, because there is an issue with the thing you are subtracting. To subtract something in algebra, we add the opposite. So write down your S function in parentheses. Whatever comes first, S came first. And then put a minus, and then write your R function. And then it just becomes, what algebra am I allowed to do to that? How can I do something to that? Okay. Well, algebraically, see that negative in front? What do? You got to distribute. And so that just becomes 3x plus 5. There was nothing in front of the 3x plus 5. So, yeah. But distribute the negative that's here to both pieces. So we get negative x plus 3 for a final answer of 2x. Thank you. Sorry. Me and my silly mistakes there. Okay, now in the second one, they want us to add the functions. Although you don't need parentheses, it's not a bad idea to write S in a parenthesis and R in a parenthesis. The plus does nothing to change the signs, so it is just a listing of those terms where we're going to add like terms together. Simplify it as much as you can, and then stop. Remember, functions are an input-output sort of thing. So what is the sum of the functions? It is just that thing. And so it's just going to be 4x plus 2. Now, here you see a number there, okay? Now, if they asked us to find S times R of X, we would put the S function in parentheses times the R function in parentheses, okay? It's not a bad idea for us to still think of it in that way, but this just means input 2 into the S function, input 2 into the R function, get answers, and multiply them together. So if I input 2 into our S function, I get 3 times 2 plus 5. If I input 2 into my R function, I get 2 minus 3. simplify each thing down using order of operations. So we would get 6 plus 5. This one right here is 11. This one right here is -1. So it just becomes 11 times -1. So it is the input of 2 into each of them multiplied then together. And so if I input 2, I get 11 in the S function. I get -1 in our R function. When I multiply them together, I get an answer of -11. I've seen where some people will write this as like a placeholder, and then they'll put the 2 under it, and they'll input their 2 there. So that is an option if you want to see the X's there, so you know then where the X's go, or you can input the 2 and then deal with it. Okay, so it's kind of up to you, but don't make these harder than you have to. It is all the things we know about algebra. It's just using function notation to kind of guide us and tell us what to do. Everybody good with those ones? Okay. Now for these ones, we have a g of x and an f of x function. And the first thing they ask us to find is g of f at -1. I'm going to just write what g of f of x is, just so we'll get in the habit of seeing that notation. So that's really just g of x divided by f of x. So that's really just our g function on the top of our fraction, the f function on the bottom. Okay, that's just what that is. Now remember, our denominator is not allowed to equal 0. So if we input and get a 0 denominator, it might be undefined. Okay, now they wanted us to input -1. So since we have that here, that's really just saying input -1 into the g function, input -1 into f function, and then divide them. If we input -1 into the g function, we get 5 minus 2 times -1 squared. If we input -1 into our f function, we get 6 minus 4 times -1. -1 squared is 1, so that's a positive 1. But when it multiplies by -2, it's a -2. 5 minus 2. I'm sorry, my square's in a weird spot, isn't it? I'm having a good day, aren't I? How about we put that there? That looks much better, sorry. If we square the -1, we get 1 times -2 is -2. 5 minus 2 is 3. This becomes a positive 4, so it's really just going to become a 6 plus 4, or 10. We did not get a 0 denominator. If we would get a 0 denominator, we would say undefined. Just reduce your fraction as much as possible. Okay. Now, B refers to this. If they just say a plain g of f, g over f, they're talking about if it was just the x's and we haven't done anything to it. It says find all values that are not in the domain. Now, we know that the only values that will be excluded are where our denominator equals 0. So what's our denominator? Well, our denominator is that. So that is not allowed to equal 0. So our excluded values are where 6 minus 4x equals 0. So we're just going to solve that. Let's subtract 6 from both sides and divide by -4. Now, when we divide by a negative, the two negatives are going to cancel. We're going to get 6 over 4, which is 3 over 2. They're both divisible by 2, so just divide out as much as you possibly can. Now, I would assume that in LX you could probably enter that as a fraction. I would assume that's probably your best bet. If you divide 3 over 2, it is a nice decimal. It is the decimal 1.5, so that is an option. So that means the values that are not in our domain are just an x value of 3/2. That's our only excluded value. If it's a quadratic, you might have to factor to find, it might have more than one excluded value. wherever our denominator is equal to 0. So G is in, or I'm sorry, F is in our denominator. So that's the one we exclude. Are you guys okay with that question? Okay. And then under here, you will find the operations. Many of them have numbers you were going to input. So let's just kind of peek at what they're asking for. For these ones you'll see, and even these ones, you are inputting a number, okay? And so you just follow along here. You're going to input 1 into the functions and multiply those answers together. Put 10 into the functions and add those together. Because remember, this really means G of 1 times H of 1. It's just a shortcut notation. This means stick 10 into the H function and add that to the value when we stick 10 into our G function. So it's just shorthand notation. This is really just you're going to find F of 4, and then you're going to subtract G of 4. Here you're going to find G of 3 over F of 3. Now those ones you're inputting numbers. So whatever you input, just simplify down as much as possible. Okay. Now, but when we get past number 6, look at number 9, those keep the x's in. So this is really just the g of x function minus the f of x function. There, it's a good idea to use parentheses. You're going to write down your g of x function. You're going to write down your f of x function in parentheses. And then to subtract them, just distribute the negative in that back piece. So that is the 3-4A and 3-4B. We will stop there so that we have time to work on those ones. And then tomorrow we'll work on compositions. Okay, so there you go.